Now student, we will discuss laws of refraction. Laws of refraction. Laws of refraction. The first law of refraction is same as the law of reflection, that is, the incident ray, the refracted ray and the normal at the point of incidence all lie in the same plane. So, what's the first law of refraction? The incident ray the refracted ray and the normal at the point of incidence all lie in the same plane. This is the first law of refraction. Now students, see, this is boundary which is separating two media, that is medium 1 and medium 2. This is incident ray, this is normal, this is the point of incidence, and as the light is going from medium 1 to medium 2, so its direction gets changed. So this will be the refracted ray. Now student, according to the first law of refraction, incident ray, normal and the refracted ray all lie in the same plane at the point of incidence. This is angle of incidence and this is angle of refraction. Angle of incidence is denoted by I and angle of refraction is denoted by small r. So this is angle of incidence and angle of refraction, and according to the first law of refraction, the incident ray, normal and the refracted ray all lie in the same plane at the point of incidence. Now we will discuss the second law. According to the second law of refraction, the ratio of sine of angle of incidence to the sine of angle of refraction is constant. So what's the second law? The ratio of sine of angle of incidence to the sine of angle of refraction is constant. Now student, I is the angle of incidence and R is the angle of refraction. So according to the second law of refraction, ratio of sine of angle of incidence to the sine of angle of refraction. This is the ratio of sine of angle of incidence to the sine of angle of refraction is constant. This constant is the property of the medium which is denoted by n. This is the refractive index of medium 2 with respect to medium 1, and this relation is also known as Snell's law. This relation is also known as Snell's law. Now student, this n is the property of the medium which is known as the refractive index of the medium or the absolute refractive index if the medium 1 happens to be air. So what is n? It is the refractive index of medium 2 with respect to medium 1, and this refractive index will be the absolute refractive index if medium 1 happens to be air. Now student, see, now student, we can write the Snell's law in the form as n1 sin I is equal to n2 sin r, where n1 and n2 are the refractive indices or absolute refractive indices of medium 1 and medium 2 respectively. Angle I is the angle of incidence and angle R is the angle of refraction. And we can write it as sin I by sin R is equal to n2 by n1, which is the refractive index of medium 2 with respect to medium 1, which is denoted by n21. Now student, these are the laws of refraction. Now we will study about refractive index. So student, now we will study about refractive index. Refractive index. It is denoted by small n. Now student, what is refractive index? It is defined as the ratio of speed of light in vacuum to the speed of light in medium. So refractive index of a medium, it is defined as the ratio of speed of light in vacuum to the speed of light in medium. Now student, what is refractive index? N is equal to the ratio of speed of light in vacuum to the speed of light in medium. C is the speed of light in vacuum and V is the speed of light in medium. C is the speed of light in vacuum and V is the speed of light in medium. So this is refractive index of a medium. Now student, we know denser the medium, lesser will be the speed of light in medium, and we know refractive index is inversely proportional to the speed of light in medium. Therefore, denser the medium, greater will be the refractive index of the medium. So, denser the medium, greater will be the refractive index. Of the medium. Now student, we know speed of light in glass is less than the speed of light in water, and as we know refractive index is defined as the ratio of speed of light in vacuum to the speed of light in medium, or we can say that refractive index is inversely proportional to the speed of light in medium. Therefore, as velocity or speed of light in glass is less than the speed of light in water, therefore refractive index of glass is greater than refractive index of water. Now student, see. Now student, we can also represent the refractive index of a medium in terms of the ratio of wavelengths of light. We know C is the speed of light in vacuum, which is given by f lambda naught, where f is the frequency of light in vacuum and lambda naught is the wavelength of light in vacuum. F is the frequency of light in vacuum and lambda naught is the wavelength of light. Now student, we know the speed of light in medium is v, which is equal to f lambda, where f is the frequency of light in medium and lambda is the wavelength of light in medium. When light goes from one medium to another, its frequency doesn't change. So f is the frequency of light in medium and lambda is the wavelength of light. In medium. Now student, we know refractive index of a medium is C by V and is equal to C by V. When we divide these two equations, we will get lambda naught by lambda. So we can define the refractive index of a medium as the ratio of wavelength of light in vacuum to the wavelength of light in medium. So, and can also be represented in this form. This is the refractive index of medium in terms of wavelength of light. So students, so far we have discussed about the laws of refraction and refractive index of a medium. Now student, we will study about relative refractive index. Relative refractive index. Relative refractive index. So what is relative refractive index? It is refractive index of one medium with respect to other. So it is defined as the refractive index one medium with respect to other. It is shown by the symbol N21, which is the refractive index of medium 2 with respect to medium 1. This is refractive index of medium 2 with respect to 1, and N12 is the refractive index of medium 1 with respect to medium 2. This is refractive index of medium 1 with respect to 2. So this is the refractive index of medium 2 with respect to medium 1, and this is the refractive index of medium 1 with respect to medium 2, and the relation between these two is N12 is equal to the reciprocal of N21, or we can say that the refractive index of medium 1 with respect to medium 2 is the reciprocal of refractive index of medium 2 with respect to medium 1. So this is the relative refractive index. Now student, to understand the concept of refractive index more clearly, let us solve a numerical. Write down the question. The refractive index of glass is 1.5. Now student, as you can see, refractive index is the ratio of speed of light in two media. Therefore, it is unitless, and the refractive index of glass is 1.5 and that of water is 1.33. In which of the two media light will travel faster and by what factor? So student, what's the question? The refractive index of glass is 1.5 and that of water is 1.33. In which of the two media light will travel faster and by what factor? So student, in the question, refractive index of glass and water is given to us and we have to find out in which of the two media light will travel faster and by what factor. So student, let's solve this question. Now student, we know the refractive index of a medium is defined as the ratio of speed of light in vacuum to the speed of light in medium. Therefore, Ng is equal to C by Vg, where Ng is the refractive index of glass and Vg is the speed of light in glass. Let's mark this equation as 1. And Nw is the refractive index of water, which is given by C by Vw, where Vw is the speed of light in water. Let's mark this equation as 2. Now student, as from the question we can see the refractive index of glass is 1.5 and that of water is 1.33. And we can see the refractive index of glass is greater than the refractive index of water, as Ng is greater than Nw. Now student, as we know, greater the refractive index, denser is the medium, and we know denser the medium, lesser will be the speed of light in the medium. Therefore, Vg is less than Vw, or we can say that speed of light in glass is less than the speed of light in water, or we can say that the light will travel faster in water. This implies that light will travel faster in water. Now student, we will find out by what factor the speed of light in water is greater than the speed of light in glass. Now student, we have these two equations. Equation 1 says Ng is equal to C by Vg and Nw is equal to C by Vw is our second equation. Now we will divide 1 and 2. Dividing 1 by 2, we will get Ng by Nw is equal to Vw by Vg. Now student, on substituting the value of Ng and Nw, we will get 1.5 by 1.33 is equal to Vw by Vg. We will get Vw is equal to 1.128 times Vg. Therefore, the speed of light in water is 1.128 times the speed of light in glass. Hope this question is clear to you. So students, so far we have discussed about refractive index and relative refractive index.